of 1.1 minus the dry air value. So this will give you 0.974. Okay. Similarly, for the humid heat, how will you work out for the humid heat? You will see that there are two lines. One is for the, sorry, for the heat, that is for the enthalpy. For the humid heat, you know already the formula, right? For the humid heat, you already know the formula. 1005 plus y bar into how much?
1.88.
1.005. So that is 1.005. Then you will give this value as 0.03 into 1.88. Whatever this is in terms of kilojoule per kg of dry air, right? Per Kelvin. Now coming to the enthalpy also, you can easily work out what should be the enthalpy values. So for the enthalpy again, we will take help of these two saturated curves and the dry curves. So we will work out what is the enthalpy value of the saturated curve, and we will work out what is the enthalpy value of the dry air, right? And then we will work out that how much is the enthalpy, right? So the enthalpy here is the enthalpy of the dry air plus we multiply with the percent humidity value, and then we will take the difference of the enthalpy of the saturated air minus enthalpy of the dry air, like the same way how we did it for humid volume. If you work out these two, it will come to around 130 kilojoule per kg. I want you to confirm this for me. Achha, then final important value is the relative humidity. Right. So for this, I want you to explore that how will you work out the relative humidity in this case. I give you 10 minutes for that. Please work out how will you get the relative humidity in this case. And also please confirm for me the value of the enthalpies in this case as well as the humid volumes. I mean, it will be around 0.97, I guess. And relative humidity, please work it out. I mean, this will be close to the percent humidity. It may or may not be close, but what is the, I mean, how will you estimate the relative humidity in this case? Please work it out. Okay, I will give you 10 minutes for this to think and to work it out possibly.
Sir, can you please show your screen?
So anyone has any thoughts in mind on how to work out the relative humidity? Siddhant? What about the other guys? Shashank?
Hello, yes, sir.
Yes, can you turn on your camera?
Webcam is not working, sir.
Whenever we ask, that is never works. And Varun, can you turn on your camera for me, please?
Yes, sir.
And Vardhan.
Yes, sir.
So how will you calculate the relative humidity? Varun and Vardhan. And please turn on your camera. Shashank, how will you work out the relative humidity?
Sir, we have to count this partial pressure for the water vapor at this point 55 degrees Celsius and 0.03, and and after that we have to find the vapor pressure at the same point for the
So how will you
given
calculate
water.
the partial pressure of water vapor? Yeah,
Like,
that is the correct approach. But how will you work out the partial pressure of water vapor?
sir, can we do it this way? Like, we draw a vertical line from the dry bulb temperature axis at 30, and then draw the line of, I
At
guess,
30 or 55?
55. Sorry, sir, at 55,
55 there.
and then we draw a line of the wet bulb temperature on the line of.
Say, continue. Let me hear out. Vardhan, continue what you are
Yes,
saying.
sir, like I was telling that we'll draw from 55 degree, we draw the vertical line for the dry bulb axis, dry bulb temperature, and then we'll draw a line for the wet bulb temperature axis, and then where these two are intersecting, we'll
So hang on. You want to draw a vertical line from the. So do you have the, by the way, do you have the psychometric chart with you? Can you try to work it out also yourself, as you say?
okay, sir. Like I don't have a physical copy, but yeah, the soft copy.
But I
Yeah.
specifically mentioned no to get the physical copy.
Sir, sir, all the shops at
Otherwise,
IT are closed. Printing
but
shops.
you
I
have
don't.
arranged. No, in the last class only I told this from somewhere. Other people could have managed. So you mean to say I will draw a vertical line from this point? Then what? Then
Sir, for the vertical bulb temperature axis also we will draw one line, and then where they are intersecting at the
let us say I
mention.
draw this line. Then and for the wet bulb temperature I will be drawing like this. Then
Then those 3 point intersect as like at that shown point.
where it will intersect, how this will intersect? Can
Well,
you see my screen?
yes, sir. Yes, sir.
So how this two will intersect? I mean, this adiabatic saturation line is going this way, and the vertical line is like this. How these two will intersect?
So they are intersecting at the where you have drawn that.
So that is the point, starting point. That is the starting point only. Isn't this quite silly? If I draw two lines from one point, starting from a particular point in two directions, they will be first intersecting there itself at the point where I'm starting. Or am I missing something? You want to say something else?
So just a minute. Just.
Sir, we know that relative humidity is, when relative humidity and absolute, sorry, percent humidity, when they are same, uh, when they are 100%.
Yeah, then percent humidity and at complete saturation, percent humidity and this relative humidity, they are same. So
Yes, what I was saying that we will reach that point of 100% absolute humidity, and then we can find out relative humidity.
how how will you reach the 100% relative humidity point? This point, what you mean to say is that the point where it reach this particular region, that will be corresponding to the, this 100% humidity line here is same as the 100% relative humidity line. But that doesn't mean the rest of the humidities are same as the, rest of the percent humidity lines are same as the relative humidity lines, isn't it?
Yes, but like the vapor content would be the same. Like at whatever temperature we are trying to find the relative
Yeah,
humidity.
but the definition of relative humidity is the ratio of the partial pressures, no, not on the humidity.
Okay, sir.
We need the ratio for the partial pressure at the in the current situation to the equilibrium partial pressure. So what we will
Exactly.
do?
So the
Yeah.
question is that how will we estimate? So as I was writing, how will you estimate, or how will we estimate this partial pressure of water vapor at 55 degrees?
We can do that from the
Corresponding,
absolute. We
for
can.
this air having, dry bulb temperature 55 and having moisture content 0.03. So what would be the
Uh,
partial pressure of that value?
we can do that from the absolute humidity. We know that in every kg of air, there is 0.03 kg of moisture content. So from that, we can figure out the mole fraction of the water content. And from that, we can multiply that to the atmospheric pressure. And we can figure out the partial pressure of the water. And then we can do that the same. We can do the same thing for when the line is extended to the saturation, and then we reach the absolute humidity, which is 0.115. We can do that for that case, and then we can divide them to get relative humidity.
Yeah, correct only. So only one correction, small correction, that when you do this work out this partial pressure, so once you get the this molar humidity, it's not only multiplying that with the total pressure, you have to divide it by one. What I mean to say is that, let me write it out. It will be clear. This will be equal to the total pressure multiplied with the molar humidity. So this is the molar humidity. So you can easily convert it out. From the mass humidity, what would be the molar humidity values, and divided by 1 plus y, right? Because these humidity values are in per kg of the dry air, right? Not in kg of the air. So that is the reason why I'm dividing by 1 plus y. So this is how you will be getting it for PA. And in the case of PV, you will do the same thing, except that these would be your saturation humidities. This is one way, or you can also use the Antoine's equation to calculate out the vapor pressure at 55 degrees. Either way, it will work. So can any one of you tell me what would be the partial pressure? Not the saturated one, but this air, and what would be the vapor pressure values? So this one is approximately 4.5 kPa for me, because I just worked out. And this one, around 15 kPa. So can any one of you confirm these two values for me?
It was 17.3 for me. The second one, 17.3 kPa approximately.
17.3 kPa. Okay, anybody else? You calculated by this, finding out the saturated humidity value, right? And not
Yes.
the Antoine's equation.
Yes.
Okay. Anybody else? So approximately, I want others also to confirm with me that you are getting these values. Can anyone else confirm me? Yash?
So it is 29.6%.
No. What is the value of this PV that you got? Vapor pressure.
So PV is 15,729 Pascal.
And how did you calculate?
Sir, by vapor pressure is 118 mmHg at 55 degrees Celsius.
So how do you get 118 mmHg? How do you know
From
that?
internet.
From internet.
From
So this is how you will going to learn. So do you understand anything that how we calculated this out? And why do you trust the internet values? Come on, guys. I mean, I want you to work out. I mean, there is no other way of bypassing this. You cannot take values from the internet and project it here. Okay, so let me frame one small question for you. Let us say you have air, water, vapor system. Guys, you have to actively participate. If you think you can just bypass, I mean, you can work it out. I mean, you can take some values from somewhere and project it that you're getting these values. I mean, you are only, what should I say? Or how should I say? You're only, making fun of yourself only, right? To claim something you are getting, but you actually do not know how you are getting. Let us say the air water vapor system is at 80 degrees centigrade and it has the humidity value of 0.03. Right? This is the air that we have. It is very hot, 83 degrees temperature, and the humidity value is 0.03 kg of water vapor per kg of dry air. Now it is cooled with water which is at the adiabatic saturation temperature. Now I do not tell you what is the adiabatic saturation temperature, but very easily you can work that out. Now it is cooled to 90% humidity, right? Now I want you to tell me what is the final temperature of the air. Please try this out. I hope the question, sir, is clear to everyone. Shahil, do you have the psychometric chart with you? And this list of names should be visible to me at the side of my screen. Anyway, Shahil, can you respond? And please turn on your camera. So actually, how many of you are in the campus or in the home? Is anyone at home?
Yes, sir.
Abhishek, anybody else?
Yes, sir.
A few of you are at home also. Okay, no problem. Uh, but still, I believe, you know, all of you should participate actively. Vardhan, please turn on your camera. I'm tired of seeing your smiling face in that icon. Please turn on your camera.
So like it would be very weird if only I am the person turning on the camera. So.
No, please don't make excuse. Either you tell me what is the answer or you turn on your camera. There is no weird. Am I looking weird?
No, sir, like I mean, in my batchmates.
No, 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 no. Nothing will happen. You turn on your camera. There's nothing to hide and it's to shame. What about Varun? I don't hear anything from you.
Yes, sir.
So Varun, please turn on your camera. And please tell me how will you find out this final temperature of the air? Bhavna?
Yes, sir, I'm trying.
So those of you are in the campus, please turn on your camera. Internet is free here. I think this is a strategy we'll try to follow in every class from now on. Guys, please turn on your camera so that I can also see you and it will also make you more attentive towards what we're trying to do. Come on. What is the issue? Why don't you cooperate? What is should be ashamed of? God help you. So anyway, anyone has any clue on how to work out this problem? Or if you already got the answer, you can explain to us. Shoham?
Yes, sir. So like from the point of 83 degrees and like 0.03 absolute humidity.
So the first step is to mark this point, right?
Yes, yes, sir.
Okay. Then
So then I think we should move on adiabatic saturation
correct.
line. So we'll go like diagonally.
Yeah, sort
And
of.
then
Diagonally though. Yeah. Then
I think we should stop, I mean, at 90%,
so,
the curve of 90%.
so did you get the answer in that case?
Yes, sir. So, I mean, it's,
Something like this you mean to say?
yes, sir, coming close to 41 degrees Celsius, I think.
And with that you try to move along this line. So luckily this is one of the parallel lines that we already have.
Yes, sir,
And
and
this
then
is the
down.
point that we'll be getting, right? So for around 41 or 42 degrees. Does all of you get this?
Yes, sir.
Okay. Let us try one more question. This is a slightly different one, where the adiabatic, this wet bulb temperature and the dry bulb temperature are mentioned. So the wet bulb temperature and the dry bulb temperature of the air is mentioned. This is 35 and this is 65. Okay, from here you have to work out what is the percent humidity value. Got my point? Nothing is mentioned about the YR water vapor system. No humidity values are mentioned. Only its dry bulb and wet bulb temperature is mentioned. Right, and this is a very practical problem, and this is what the weather forecast, this weather meteorology guys actually do. For the normal air, they measure the wet bulb temperature and the dry bulb temperature, and from there they estimate out the percent humidity value. There is as such no this sort of moisture sensor that is used. Right, you get this value from the estimation of the dry bulb and the wet bulb temperature. You work out the humidity, percent humidity, and the relative humidity value. So let us say the dry bulb temperature is 65, though it is quite on the higher side. Normally in atmospheric conditions you don't see 65 degrees to be the dry bulb temperature, and the wet bulb is 35, but just I have exaggerated this value so that it is easier to compute. Now, from based on this, you must work out what is the percent humidity value. Yes. Any idea?
%14.
No. How do you get it? Without getting to the final answer, can you elaborate? How do you get it?
Sir, on the psychometric chart, like if we follow the 100% humidity
So
curve.
yeah, I hope you also worked it out yourself and then said the answer.
Yes, sir.
Okay, yeah, tell me. So we cannot
Sir,
identify one particular point, right? Because we do not have the information about humidity, enthalpy, or anything. You only know the knowledge of 35 degree and 65 degree. 35 is the dry bulb, wet bulb, and 65 is the dry bulb. So we cannot locate a point actually.
sir, like if we draw perpendicular line at 35 degree and
Mhm.
see where it meets the 100% humidity curve.
So I want to draw a perpendicular line at 35 degree.
Yes, sir.
So I am drawing a perpendicular line. Then, sorry,
And
I
then
this.
we can see where it meets the 100% humidity curve. And from that point, we can follow the adiabatic
No, no, hang
saturation
on.
curve
Hang on.
downwards.
Let me also draw it as you say, so that it will be understandable to everyone. So let us say this is my vertical line, right, at 35 degree. Then what I will do?
From the point where it meets the 100% humidity curve,
This is the line.
we can
From there
follow
I
adiabatic saturation
have
curve
and go all the way up to
65 degree.
excellent this point. Then
Yes, sir. And then we can interpolate it using the 10% and 20% humidity curves and can get the value at that point for percentage humidity.
correct. So the humidity value at this point is around 0.024 or 5, isn't it? And you also get the, so this is at 65 degrees. You can also get the saturated humidity value by doing a vertical, this vertical you can get what is the saturated value, and you take the ratio of these two will also give you the percent humidity value. So this is clear, right? Okay, so I want you to note down one problem because we are running out of time today. Please try to attempt this problem during the next few days, right? And in the next class, we'll of course discuss on that problem. Guys, it is very important that you participate and you work out these hand problems. So let me dictate the problem. So you have air which contains 0.005, it's very low humidity, kg of water vapor per kg of dry air, and this is heated to 325 Kelvin. Right? You can also write down the corresponding this centigrade value, so that is around 52 degrees, right? It is heated to this 52 degrees in a dryer. So this is an actual realistic industrial tray dryer question. So you have air which is 0.005, it is heated to 325 or 52 degrees centigrade in a dryer, right? And this one, and once it is dry, I mean once it is heated to this part, it is then passed to the lower shelves. So you can think of this to be a sort of this arrangement. And you have this heating arrangement here. So air is getting heated up and then it is passed to the lower shelves, right? This air, once it is getting heated up, it is passed to the lower shelves, right? So once it goes to the lower shelves, it leaves with 60% humidity, right? So humidity content, so this obviously means the air that you are introducing into the heater or whatever is leaving from the heater is much lower than 60%, and essentially here you have some wet solids, right? Here you have some wet solids which needs to be dried using dried air, right? So in the process, air gets humidified and the solids becomes dried. So once you dry them out, the air takes up that moisture and becomes humidified to 60 degrees, 60%, right? Now this 60% humidified air is again, without, you throw it outside, you again pass it through the same heater at the top. And then again it is passed to one of the other shelves where you have some other, solids to be dried. Like this cycle actually goes on 4 times. So let us say this is like the bottom tray. So you have 4 trays in this shelf. So this is bottom tray, then second, third, fourth. Sort of. I mean, this may not be the appropriate drawing that I'm getting here, right? And you heat always at the first, row, and then the air always goes into one of the dryers and leaves at 60% humidity. That's how it is designed, right? And again, it is heated to 55 degrees. So 52 degrees, sorry. Right, and this continues for 4 cycles and finally it leaves the chamber or the dryer. So initially the air that you introduce into the system has a humidity of 0.005, right? This is what you know. No temperature is mentioned and this air is heated to 55 degrees. It goes into the 4 chambers. Okay, now there is one assumption, and this is quite critical for this problem actually. in each of these trays or in each of these shelves, the material reaches the wet bulb temperature of air, right? So since the material reaches the wet bulb temperature of the air, naturally you can understand the air that leaves in each of these shells is at its wet bulb temperature, right? Okay, so now what you have to find out, the first one is the temperature of the material in each tray. Okay, and the next, the amount of water vapor that is removed in kg per second, right? Assuming or considering, not assuming, considering, let us say 5 meter cube per second of moist air leaves the system. This is the idea of the volumetric flow rate of the air that is leaving the system. So based, I mean, considering that to be the basis of the calculation, how much of the water vapor or the moisture content is removed in this process from the materials, that is something you need to work it out. Or what is the rate of removal? So please try to work this out. We will definitely discuss on this problem in the next class, but I also want you to try it yourself first. Okay, so with this we'll end today's class, guys. I still hope and I do anticipate that you will, participate much more actively in the class, right? Otherwise this hands-on exercise or this problem, working out the problems, will not be actually used. I mean, it will not help you, right, unless you participate more. So please participate. This is what I strongly encourage and I really hope for that. Okay, so we'll stop here today. Any questions on what we discussed today?
So what is y in the previous example? I still don't understand.
Please say again.
Sir, what is y in the one where we calculated relative humidity?
What is y?
Sir, what y is it? Is it the 1 second? Is it the absolute humidity or is it the like?
See, y prime, y bar, all are absolute humidity. Y bar is humidity in terms of mass units. Y is humidity in terms of mole units. You mean
Okay, sir.
here, right?
Yes, I understood.
This
Yes,
is the molar humidity. Unless humidity is in moles or in molar ratios, you cannot apply this sort of, this mole balance and this Dalton's law.
yes,
Okay,
sir.
in mass
Understood.
units it cannot be done. So only you have to get it in mole fractions or in some molar scales.
Yes, sir.
Then only these partial things will work, isn't it? So
Yes.
you know how to convert the mass to the molar humidities.
Yes,
I
sir.
think in one of the very beginning classes we discussed that. And so the whatever the value that is mentioned is in mass units, that you convert to molar units. And then
Yes, sir.
based on that you work out the partial pressure. Okay. Anybody has any clarifications that you need? No? If not, then we call it a day. Enjoy the rest of the evening and the weekend. We'll again meet each other on Tuesday's class. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.